So test the series. N equals 1 to infinity, negative 1 to the n minus 1 over n for absolute convergence. So all I'm going to do is I'm going to put on absolute values and see what happens to my series, okay? We're just using the definition of absolute convergence. So put on an absolute value. So maybe the step that will also help you, I'm going to write here. When you have the absolute value of a product, or in this case division, you break it up into the absolute value of the top divided by the absolute value of the bottom. Okay? Isn't what? You're just thinking. Okay. So the bottom, right, n, that's always positive. The absolute value of a positive number is the same thing as what you started with. So the denominator is just going to be n. And the numerator, what does that become? 1. What series is that? It's a p-series, or it's also known as the harmonic series. So either way you want to go. P is 1. P is less than or equal to 1, and so it's going to diverge. Or you could know that it's the harmonic as well. So in this case, when I put on absolute values, it didn't converge. I got something that diverged. So I now can say that this series that I started with is not absolutely convergent.
Is this a different problem that we just did?
Yeah, the other one I had n squared in the denominator. This one I have n. So I'm starting with a different series, but it's the same question being asked. So in the first example, we had something that was absolutely convergent. I put on absolute values, it converged. This example, I put on absolute values and it diverged, so it's not absolutely convergent.
So we're just testing this if it's convergent or not.
If it's absolutely convergent, not convergent. But since you brought it up, now's a good time to ask. I found out that this series, that in this problem, it was not absolutely convergent. So the question, so now I want to ask this question of us. Question: what does that mean for convergence? Does this series converge or diverge? I know it was not absolutely convergent, but now I want to know, just back to our regular convergence or divergence, does this series converge or diverge? This is an alternating series, right? We've said that. So I can use the alternating series test, so let's do that. We did that before. What's my Bn gonna be? 1 over n. You remember the two things we need to show for alternating series? Decreasing, and the limit is 0. So I'm going to compare Bn plus 1 to Bn. I think we actually did this one last time, but we'll do it again. Which one of these is bigger? If you need to cross multiply to figure out which one is bigger, the 1 over n. Exactly. So I have a decreasing sequence here of Bn's, And I'm going to now take the limit of Bn 1 over n, that's 0. So what's my answer? Does the series converge or diverge? Alternating series test only tells us a series converges. Yeah. Yeah, so I met my two conditions that I needed to. So if you need to, think about these as being check marks, check, check. And now I can say my series that I started with, -1 to the n minus 1 over n, converges by AST, alternating series test. Okay? So we had a series that is not absolutely convergent, but it still converges. That's a special thing that happens. It doesn't happen all the time, and that's what we're going to call conditionally convergent. Okay? So let me write that down. Definition: a series, sum an, is called conditionally convergent if it is convergent but not absolutely convergent. Okay. So really, when you're saying something's conditionally convergent, you're testing two series for converging. The first one with absolute values, and the second one is the original series you start with. Okay? So in some way, it's almost like twice the work. So we said that a series can be convergent, but not absolutely. So what about the other way around? Could it be absolutely convergent, but not convergent? So second question we want to ask: can a series be convergent but not absolutely, or sorry, can it be absolutely convergent? I gotta switch these. Yeah, can it be absolutely convergent but not convergent? And I'm going to tell you the answer is no. No. Any series that is absolutely convergent has to also be convergent. You would think. They're two separate things, though, but it just happens that there's this theorem that tells us just that. If a series, A sub n, is absolutely convergent, then it's also convergent. So this really isn't a test, but this gives us a new way of verifying that a series converges. If you can show that it absolutely converges, then you would know that it has to converge as well.